All right, so it seems like many, many years ago, it was probably just a year and a half to 2 years ago, in a section of 342, probably right around week 6 or week 7, down in the older lecture halls, there was a student. And they sat right-ish about there, I remember. And they came up to me after class, and they said, "Do you know anything about exploding chickens?" Which I said, "Of course I do." I had no idea, I lied. But the way that they said it, it seemed like I should have known what they were talking about. Turns out that that student, along with some of their colleagues, were working on a real network game. So building the front end, the middleware, the back end, for a game called Exploding Chickens. Which was quite ironic because, as all of you know, we were simulating networking and have been for the last few weeks. And this particular student and their colleagues, they were trying to do it on their own. What happened is over the next year, we had a few meetings and kind of talked through the code, talked through how it was organized. They made several revisions of it. And then last semester, that one particular student said, "You know, do you think that the students in your class, do you think it'd be helpful to talk through my experience trying to do this?" And I said, "Yeah, I think that would be really interesting. It's one thing for me to talk about. It's another thing for a colleague of yours to talk to you about trying to do it in earnest." It went really well. A few weeks ago, actually that's not true. At the beginning of the semester, that particular student emailed me. It took me a while to get back to them, and I said, "Yeah, we can do that again. Let's see when it fits in." And then about 2 weeks ago, they emailed me again and said, "Hey, just remind you about this. The semester's almost over." And I said, "Yep, let me think about if we can fit it in." And then I do believe within, 2 days ago, I said, "Let's do it today." Yeah, okay, so right on time, as usual. So what I want to do, it's really interesting, and I think that a lot of the things that we talk about in this class, you're going to see really, in a way, I think with some of this development, they probably would have liked some of the tools, at least the planning tools, the organizational tools that we talk about. It probably would have saved them a bunch of time, but it's really interesting to hear, and I'm actually curious to see the state of this, because we haven't talked in a little while, and I'm imagining it's pretty good, because you're smiling. I suppose if it was a disaster, you wouldn't have asked me to be here again, right? So, anyways, I'm going to hand everything over to Professor Hallenback. It gets ugly, I'll be back here.
Okay, sounds good. All right, first off, thank you, Professor Hallenback, for letting me be up here again like last time. But overall, today we're going to go into a full stack card game, pun intended there, of a game that my friends and I built during about the same time in 2020, so about 2 years ago. So kind of how this started is me and my friends made this card game called Exploding Chickens, because there's this original physical card game called Exploding Kittens, which I'm sure many of you are familiar of. And back in high school, my friends and I, we wanted to play this game, but we didn't want to buy it because we were cheap. So we essentially designed all of the cards ourselves, printed them out on paper, and played at our lunch table. So that's what we kind of did there. But then, we're all off to college, we're not in high school and, in person. So I'm like, hey, what's the super overkill idea is to, make this physical card game into something that people can play online and people with COVID can really take advantage of, and not have to pay $5 for the Exploding Kittens app. So with that, that's kind of where this was born. We've gone through revisions upon revisions to get to the point that we're at today, and we'll get there eventually. But first off, who the heck am I? I'm Professor Hallenback. Right now, I'm a third-year computer science student here at UIC, so I'm in basic kind of the same, shoes that most of you are in. So I took this class a year ago, so the fall of 2021, and then the semester after that, I gave it a super similar lecture to this. This is the second go at it with a lot of improvements that we've had. So without further ado, let's get into the game a little bit. So I'm assuming you have no knowledge of how exploding kittens work, so we're just going to explain how the card game goes. At first, on setup, so with the card game, are they still doing the Baccarat game? No? Okay. Anyways, the initial setup for this game is there's a draw deck that has 52 cards in it. That draw deck contains these things called exploding chickens. There's exploding chickens now. And there's always, in the deck, there's always one less than the total number of players in the game. In a standard game, there can only be up to 5 players in a game. So if there's 5 players, there's going to be 4 exploding chickens. But then on the very first start of the game, the deck is initialized to 52. We deal 5 cards out to each player, not including the exploding chicken. And that's kind of how the game's set up. Each player has 5 cards, and then the deck that remains, so whatever cards are left after 52, is kind of, that's how the game starts. So first off, the exploding chicken, or how this game goes, is everyone takes turns drawing from the draw deck, and then if they happen to draw the exploding chicken from the deck, there's like a very slim chance. But as you get further and further down the game, where cards keep getting drawn off, then there's a more likelihood of you drawing this card. So this is the really pretty nice description of what that card does. And the contrast on the monitor is not that good, but this is like the pretty description. This is what's on the website. And if you don't have what's called a diffuse card, then you're like, if you can't diffuse the exploding chicken, then you're kind of out of the game. And that's how it goes. And your goal is to be the last one standing. So beyond that pretty description, this is the CS perspective of what that card is going to kind of do whenever it's drawn. So when we first start, if the card is drawn, we're going to check 2 if-else conditions. If they have the diffuse, they should play it. They have the option to not play it if they choose to. But if they play the diffuse like they should, it puts the exploding chicken back in the deck, and they can choose where they want that to be placed in the deck. So at any point in the deck, they can choose that. If they don't have a diffuse, then they explode, they're out of the game, they've essentially lost. So moving on to the diffuse card, it follows a different logic. So if this card is drawn from the discard deck, or the draw deck, sorry, it's just placed in the player's hand. If it's played so they only can play this while they're exploding. That's the entire purpose of this card. So if they play it and they're exploding, they discard the card, it goes into the discard deck. We prompt them to, where do you want to put this exploding chicken back? And then we advance their turn to the next person. So other cards kind of, follow this same idea. The shuffle card is something that seems very simple. All it really does is shuffle the draw deck. So again, if the card's drawn, put it in the player's hand. If it's played, shuffle that draw deck and then discard the card. That's really all it does. So you may think that seems really easy and intuitive, but in terms of trying to design some type of game that can, or some type of system or program that can understand, hey, I want to play a shuffle card. In order for the computer to understand how to play this, it's way more complicated once you really look into it. So first, you have to know that the player wants to play that card. Either they click a button, there's some trigger that says, hey, the player wants to do this. So they say they want to do this, it's on some sort of play card request. And then we do this kind of like validation phase, because we don't want them playing it if it's not their turn. Does the player even exist? And do they even have this card? Is somehow a different player playing this card when they shouldn't be? And again, can they play it now? There's if they're exploding, there's no reason to shuffle the deck, or the rules of the game is you can't really shuffle the deck if you have an exploding chicken and you're trying to defuse it. But say all that passes. Then after that, we complete the card actions. We actually randomize the draw deck. And we don't do anything if it fails any of those previous validation steps. Then we discard the card, and then finally, to wrap up, we have to tell everybody what happened at the end, regardless of the outcome. So did they actually shuffle the card, or did they actually shuffle the draw deck, or did it fail one of these errors, or what have you? So with that, there's We've only gone over a couple cards here, but there's a bunch of other cards that we've made for this game. The first top 2 rows are cards that are explicitly pulled from the Exploding Kittens game, so they mirror them exactly. The bottom row is our first expansion pack that we released about a year ago, and that's all new stuff to us, and all new stuff that me and my friends, designed and kind of thought up with new ideas. So like one of them is, it's pretty brutal, but it's called Scrambled Eggs. If they play this card, it basically shuffles everyone's, so if you have a pool of everyone's hands, not including the discard deck, it basically shuffles everyone's hands. So you could have some cards 1 minute and then have somebody else's hand or a mix of them the next minute. So we released those expansion packs, and to date it's been quite an interesting, it's been really satisfying for me to see like the numbers slowly trick up on this game. But we started this game in the winter of 2020, so right going into winter break, I'm like, hey, I got this idea. We thought we were going to finish it by the end of winter break in about a month. It ended up taking until April of that next year. So it took about 4 months to get through that entire process. And that's when we released in April of 2021. To date, we have 900 games played on the platform. With those 900 games, there's been over 7,000 minutes of playtime. So people have been actively staring at the screen, clicking the buttons, doing stuff with the game for 9,000 minutes or more. And then with that, there's the discard deck. There's just a button there. There's just the discard deck. People have clicked that button 31,000 times since we first released. So with that, this might be a little risky, but I think we're going to try to go into a demo this time, because the last time I gave this lecture, we were not able to give a demo because the original version could only support 5 players. But with the new framework, we can support everyone in this lecture room. So with that, if you'd like to pull your computers out or your phones out, I welcome you to possibly play a game. It'll be very, very short. I'm only going to let people join for about a minute, and then we'll play for about 3 minutes or 3 or 4 minutes. If you finish your game and everyone speed runs the game, then great. But if not, we're going to continue with the rest of the lecture. So first off, before we get into that, I want to just show everyone the homepage, because the link I'm going to give you is going to dive you straight into the game. If you go to the original URL, which I'll provide in a second, this is kind of what the game looks like when you load up the homepage for the first time. This homepage has actually looked like this since version 1. I think we stuck with a good design. So this is it's just a full stack web framework. There's a server that's serving a web page that you can visit. It describes how to play the game, basically what we've gone over, and then it goes over all of the card descriptions, so how all of the cards work and what they do, as well as the expansion packs. Before, expansion packs were free, they didn't cost anything. But now we're at a point where server costs are eating me alive, and because I have to pay for them month to month. And I'm definitely not looking to make any money off of this. It's just server costs kind of hurt a little bit. So we started to say, if you pay $5 for an expansion pack, you get it forever. And that's kind of how we go on from there. You just get access to this expansion pack, and that's it. But the last point to make before we get into this, and you really can't read it, but this project would not be possible without all of my friends. I was the one that kind of led everything and did a bulk of the work. But my friend Singdow at Northwestern, he did all of the card graphic design and worked on the back end. My friend Vincent at Urbana-Champaign, he also worked on the back end and worked on test coverage, so we'll get into later. And then lastly, but not least, Richard, he also worked on the back end, and we're currently looking into machine learning possibilities with the game, and working with making an AI for the game that you can play against. So without further ado, we can head into the game. If you go to this link, which I promise is not malicious, it's not going to steal your data, but it's reprimand.com/link/demo. It'll shoot you straight into a game where it'll prompt you to say, hey, set a nickname. Please be nice with your nickname. This is a college atmosphere. But be nice with your nickname. You can pick whatever avatar you want. It should place you in some games. And let me make sure that is actually working. Aha. I see. But yeah, so this is version 2 that's running. Before this, it was the only thing that was possible is only 5 people. Only one of these little sections were able to play at once. So that's it started with this like only 5 people can play at a time. If you can't get in, you're kicked out. But now we can support basically a limited number of people in one game. This is probably going to be, I think this is going to be the biggest game that we've ever played. We tried to stress test it for you guys so it doesn't break. But I'll go back to the link really quick if no one's picked it up yet. And this should be interesting. If you don't know how to play the game, I hope I explained most of it well, but you kind of just get carried along and try to do stuff while you're playing, click buttons and stuff. It should be fine. All right. So I think everyone that's going to be in is in. So how this looks for the host, or I'm the host, there's different grouping methods. So I can, if we were to play multiple games after this, I could say, okay, I want to group everyone by the win number or randomly. I can have different room sizes. So like right in this moment, I could change it to everyone's in a 4-player game and updated that automatically. So but I'll keep everyone 3-person games to keep it quick. I'll keep the timeout is at 30 seconds, so if someone decides not to play in the game, it should hopefully force them to play. Fortunately, I'm not going to be in games, but right, I guess we can get started here. If I click the button. There we go. Alright, you get a pop-up on your screen that says, hey, you're about to be placed in the game. It should automatically redirect you. Is anyone having issues with getting into a game? Okay. Well, once you're in there, have fun. I will give you the next 4 or 5 minutes to play through your game. So basically what you do is I'll hop into I'll hop into the first one where it seems like somebody's not playing. I'll hop into this game. So with this game, it's pretty much you just click on to finish your turn, you just click on the draw deck. It places a card in your hand, and the whole premise of the game is if you draw an exploding chicken, you have to defuse it. So you just kind of keep drawing. The little bomb icon in the upper right-hand corner that shows how many exploding chickens are left, along with your percentage chance of drawing that. Is anyone having problems? I hear a lot of Okay. Yeah?
Of course, I have a problem. So I got bounced back to where you see the various groupings.
Yeah. So if you're back on this huge page.
So I'm back here. So the way to get from here, you can see the game's running.
Yeah, if you click on, there's like a top, where are you at? Oh, over here. So if you click on...
That's actually not me. I'll show you who I am.
Okay, on the top. There we go.
Nice.
Yeah, that's one thing that I've noticed, or I noticed last night, was like if somebody gets somehow not in their game, if they go back to this lobby page, it should prompt them to go back to their game. So design.
Yeah. Well, I like how it tells you it's not your turn. And by the way, I do see that someone in a room is called Hallenback. That is not me. Just putting that out there, that's not me. I'm someone else. Matter of fact, if anyone can guess who I am, they'll give you $1.
That's a hard guess.
It's gonna be a cat for sure.
That's a hard guess.
Look at the.
It's not going to be an easy guess, no.
Yeah, it's gonna be.
Avatar's gonna be a cat.
I know, I think I just made a new game. All right, forget about guessing who I am.
Yeah, this seems really successful. All of you are like only 10% through the game, which is great. Yeah, does anyone have any issues? There shouldn't be any more bugs anymore, but
This is the real one.
things appear.
No, I should have put this on it. I'm so sad.
Yeah, I'm sorry if you're in a game with someone who's not playing. I can't do much about that. Alright, I'll give you guys about 2 or 3 more minutes, but I'm gonna see what games look like nobody's playing and it's still the first turn, and I'll kick them for you.
Bro, who is your boy?
I like the decrease thing.
It's hard to use on your phone, I will say. A little bit. Yeah, before, like, really no one was able to play this because it was only 5-person max. That was kind of the point of making it into the system where you can have a huge amount of people play at once.
What are my
Yeah. All right. So, ooh, 1 game finished. Nice. All right. So I hope you all have had a fun time, but unfortunately I'm going to suspend the lobby wherever you're at in the game so you can get on with the rest of the lecture. All right. So welcome back to the lobby. It won't do anything at all for the time being. All right, let's get back into we don't need to go to the backup link. But, so, again, I hope you all had a fun time. But with that, let's kind of get into the, I don't know, educational aspect of this lecture. So, based on what you experienced, you kind of have to think about a lot of things about where do you want to start to make something like this. How do you deal with 40 plus people trying to access all of this data at the exact same time? How do you tell everyone around you that, like, if you consider everyone in this room and they're all trying to speak to another person about, hey, I'm trying to play this card and all that, how do you handle like all of that traffic and deal with all this communication going all over the place? So with that, you kind of want something that obviously has room for expansion. You want something that's fast, that works. Before, when I was running this on a different server, it would lag really bad if it had like any more than 8 people in it. So how do you make something that is inherently fast and going to work well no matter where you put it? Something that's easy to understand, quick to develop. You don't want to spend forever trying to make this. And I guess, again, something that's real time and you don't have to refresh the page or do anything like that. And also maximize compatibility. So that was one huge reason why we decided to make this a web app and not an Android or an Android app or something on the App Store. Because first, we don't want to compete directly with Exploding Kittens because they had their own app. So we just wanted to make our own web version that was free to play. And there was no, like that whole expansion pack bit, there's no, like, you can play the game perfectly fine, and there's no limits to how you could use the game and play with your friends. So with that, version 1 was the very first thing that came out in April of 2021. And I'll be straightforward and upfront. It was incredibly unorganized. And it was basically me sitting at the computer, typing code without any plan, and just like basically just putting it together. And that was a huge mistake. So the stack I chose to make this web application was a very common Node.js stack that uses Node, MongoDB, and Express, which is something that runs on top of Node.js. But you may be wondering, what is Node.js? You might have heard of it a little bit. But essentially what it is like a network-focused JavaScript. So JavaScript it's an event-driven asynchronous runtime. Basically what that means is in something like F# or Python doesn't do this, or Python doesn't do this, but essentially just runs. If we encounter an error, it's going to throw that error on runtime. It's not going to like really check itself. Where in terms of errors, it's not going to like say, hey, you're going to encounter this error at this point in time. It's not going to show up until it happens. So there's no, like variables can kind of be whatever you want, as it is in Python. You don't have to type anything. You can basically do whatever you want. The developers trust you a lot, and they just use garbage collection to keep it fast. So Node.js is like a networking version of that. A lot of web applications are built on top of Node.js, as well as MongoDB, which is a NoSQL database. Basically what that means is if you think about the entire lobby, each lobby is a document that you could print out that just contains all the data in that game. And from lobby to lobby, all the data that's contained in there could actually be different. So one lobby could say, for example, have data A with all of its own things, and lobby B could have it could have completely different data. It theoretically could. That's in stark contrast to SQL, which you can think about as an Excel spreadsheet with really closely defined columns with like identified types. So there's more flexibility there, and you don't have to do what are called migrations. Migrations are basically so say you want to add some new feature and you need to add some database value. You have to do like a whole migration to try to deal with that. If you use something like NoSQL, or in this case MongoDB, you can essentially just say, okay, in my new lobbies, I'm just going to add this new field, like on the fly, and then I'm just going to have to deal with that in my code and manage for that difference in data. So we use Mongoose as ODM, which is, it basically just allows Node.js to talk to Mongoose, because MongoDB is the database out in the cloud, you can say. So Mongoose is the thing that kind of bridges the gap between Node.js and the database. Then we chose handlebars to use as our it's kind of like a fancier HTML deliverable type thing. So essentially we can say, okay, we have this HTML page, and as it's getting served or sent to your web browser, we can just insert data. So on the original home page, it shows 900 games played, so many chickens exploded. That's how we insert that data, and then it's sent to the web browser, and that's just how they just see it as that 900 games played number. And then Socket.io, it's basically just fancy WebSockets, which you've learned in this class through networking, that kind of thing. So that was version 1. This is kind of what it looks like on a visual sense. So you have the front end, and this follows a model view controller model, which I know you guys have talked about in class. And essentially, in this sense, the front end is the view. So that's what Express is the thing that serves that through Node.js. And then in order to talk between the view and the controller, again, we use handlebars to kind of send the HTML page down, as well as Express. And then we use Socket.io to keep that WebSocket, or the backend, is Node.js, which is the controller. And then again, as I mentioned earlier, Mongoose, that's kind of the intermediary between database, which is the model. So early on, we had to make diagrams. I don't know if you really put again. So early on, we had to make diagrams. Or in version 1, I did not make a diagram, and that was the problem. I don't know why I'm showing this now. This is version 1. We're going to come back to this slide. So for version 1, this is what the database schema looked like. So what we were trying to make each document look like. So first, it was just games. There's no lobbies. So you have a set of cards. You have an array, consider an array of cards, an array of players, an array of events. So what we could, and what I thought was pretty smart, is we just have all 52 cards. We don't have to keep moving these cards around. Like we don't have to. Say we have, one way to do this is say we have a list of 5 players in the game. We could store that card data directly in the player and have an array in each player called cards that contains everything. And then have something like a discard deck that does the same thing. But what I thought was a little bit cleaner is if I gave it this, this assignment parameter in each card that basically says the card knows where it can be. It knows it can be in a player's hand, it knows it can be in a discard deck, it knows it can be in a draw deck, or it can be out of play if it's, say, like the player dies or explodes. All of those cards in that player's hand are technically out of play. They're not used any longer. So that assignment parameter can just change and it knows where it's going to be. It's essentially a pointer. It just points to where it's being used. And then there's this position that has to do with where's that position in wherever it's defined. So if it's in the discard deck, what position in the discard deck is it in? It's independent, like you made a for loop with I. This position parameter is independent of that. It actually relates to where is it at in that player's hand, or the discard deck, or the draw deck. And there's just a bunch of other metadata there for the cards. The same thing goes for players. It just has a bunch of data there that indicates what the status of that player is. And then lastly, there's this like multi-use event type document that basically says, okay, this is what happened at what time. Version 1 really didn't utilize this until a release in about November. So it took about 8 months to actually even get this events system working. And there's a bunch of data that's related to the game that's in there as well. So let's jump back quickly to our shuffle card example that had that complicated thing going on. So the way we architected it there was you have the socket.io client, that's your web socket. You can just say, hey, I'm gonna dump data out, like down this socket. I really don't care how it gets there. I'm just gonna like assume that it gets up there somehow. So the socket.io client, and then there's this. So this top bit, that's the whole like web browser. And that's the part that your game is running on. Then there's the server, which is the stack below this, which is the socket handler, game action, and card actions. So there's bidirectional communication between these two layers, the front and the back end. So what happens when you say you want to shuffle a card is now the player sends that play card request. It comes down to the client. The socket handler should have some matching event that matches that play card request. And then it basically forwards it down to the game actions and says, hey, this player wants to play this player wants to play this card. And then game actions is like, okay, I'm in charge of all this game stuff. I'm going to go down to the card actions, and then it finally executes that shuffle card command. And then it traces all the way back up and tells the client, as well as everyone else that's in that game room, that, hey, player X just played this card. So then it shows on your screen that it's in the discard deck, and then it's removed from their hand, all that other stuff updates. So on super high level, that's how it ideally works. But the problem that we had with version 1, and a huge, like this may seem very intuitive, but our problem with this is the layers between socket handler, game actions, and card actions, they were so tightly intertwined to each other that if you tried to like pull them apart to do test cases on them, it was virtually impossible. The problem being is the socket handler, it would basically pass this socket object all the way down to card actions. So if I tried to run a test case, it's really, really hard to do because I would need an active connection to some web browser, which a test case, it's hard for a test case to do that. So that was the problem, is the layers were so meshed together that even if you wanted to attempt to do test cases, you couldn't. So version 2, and this is where we left off in the first lecture, was a segmented second attempt. So essentially we kept the same web stack. Instead, we introduced tests, which I know you all love. But tests were super important because as JavaScript, we only catch errors as they happen, so you have to encounter that edge. With this, we introduced 10,000 lines of test code that tests literally every portion of the test. We also created essentially just a recursive function that brute force tries everything in a game. So you can literally say as function parameters, hey, I want to spin up 100 lobbies with 1,000 players in them and just play all those games to completion. And it plays literally each player plays literally every card in its hand, and it does it randomly. So in that case, we're kind of like brute force hoping that we encounter every edge that we could, but that's just one set. In addition to that, we had to write test coverage code that covers all the functions. This like brute force system is just hopefully to catch anything we missed. So then we moved to a different repository model and how we push code. We did in-depth issues and features tracking in GitHub. And again, that new lobby abstraction that you guys just witnessed. Right now it's running version 2.0.5. So this was the version 2 schema. Essentially what that is we have that games part. It's compacted down into its own little thing now. It contains its own cards and events for each particular game. And then for each lobby, the players kind of just stay the same, except they're assigned via a pointer basically to that game that they're a part of. Again, we don't want to put the players into the games because then we have to keep moving and copying data all over the place, and that's not ideal. And then the same kind of goes for the events. So it seems really simple, but the part that's made this incredibly difficult is that at that point we had about 20,000 lines of code, like just for the project, which seems huge, which it is, but that also includes like all the front-end code. But at that point, all the function signatures, they were looking for game objects, and we had to switch absolutely everything over into accepting lobby objects. So that was the thing that took forever, and why we should have designed it a bit better to deal with a higher level of object. So first I just want to go into the releases. So kind of with that, kind of show you the progress of where we're at. So version 1, can't really read that well, but I guess I'll just scroll through to show you the magnitude of what's happened. So version 1 in April 2021, that was the first release. Went through a bunch of updates. Eventually we released the expansion pack in July of 2021. A bunch of stuff went on. And then right in October of 2021, we realized this issue of, right when I was taking this class, I was like, shoot, I can't make this project any better because I designed it poorly. So that's where we almost scrapped everything, and that's where version 2 came out. So it went from October 2021 all the way to April of 2022 this year. That's when it was released, and then now we're just sitting at a release in October of this year. So we have all these issues that we're working on that are, so this is the GitHub repository. We all have all this stuff we want to do. As of right now, there are no bugs I'm aware of, but a feature enhancement that I might add after this lecture is if you get into the lobby and you're not in your game for some reason, there should be a pop-up that says, hey, here's a link to get to your game that you should be in. So that's some feature enhancement that I might add. But that's kind of how we keep track of everything. The code base is still massive. There's a bunch of folders containing all types of stuff. There's folders defining each schema. There's this services folder, which is basically the logic backbone of this project. It contains basically how everything works, and then the test cases test all of these files. But that's not it. In the last 5 minutes, this is where version 3 is heading, which is going to be another complete rework again. So, version 2, I'm super happy with where it's at, but in version 3, nothing in terms of what you experience in the game is going to change, but everything on the back end, or almost everything is going to change. So right now, the game you just played, if it's hosted on some server in the cloud, it just is running there 24/7, waiting for you to play the game. And that costs a lot of money, because you're paying to say, I'm reserving this spot, and it's always mine, and say nobody's playing for like 2 days. It's kind of a waste of time, or a waste of money, to have to keep paying for that. So with version 3, we're turning exploding chickens, or at least the back end, into something that's called serverless. Essentially what that means is anytime that you say, okay, I want to play, or I want to see the homepage, like that's it. You go in, or you go into the homepage, or say the homepage is requested, it comes to this thing called Cloudflare Workers. Cloudflare Workers, within milliseconds, spins up this instance that serves that homepage and then just exits. So what that does for us is we're only paying for the milliseconds of compute time that we're actually using instead of constantly using a single server. But that means we have to, rebuild our entire backend to work with some sort of serverless system. So that means we have to move away from Node.js, because Cloudflare is now dealing with all of this. And if you're not aware, Cloudflare is basically a huge internet provider, and they've been doing really, really cool advances in internet technology. I highly encourage you to take a look at it. But they're doing some really cool stuff. It's really, I think it's really neat. And I've been aware of it for a while. I'm just like, man, I don't want to do this, but I feel like I'm going to have to. But essentially what that will mean in the long run is exploding chickens will run worldwide on the network edge, which means it'll run on servers closest to you. So it'll run one in Chicago, and if you're in China, it'll run one in China. So it runs everywhere. So that means if I'm in China, I don't have to make a request all the way to the US to try to play a game. So it's decentralized everywhere. It's also super lightweight, so it needs to be fast to run at a moment's notice. But it's also, the top bullet is, it's a completely new web stack. Before we're just using JavaScript functions, but now we're having to move into TypeScript, which is object-oriented, which means we have to define, instead of defining schemas for a database class, now we have to define a TypeScript object class that we can store each private and public member variables within that class, and we'll just instantiate a new lobby, or a new lobby object each time, and that'll just be kind of thrown around. So we have to completely, like the code kind of stays the same, because the whole front end's going to look the same, but we have to move everything into a new framework that has, this test coverage will be the same, and everything should run faster, and at the end of the day, that'll get us from however many dollars I'm paying a month for the server and the database to cents on the dollar that it's only billed for if someone actually uses it. So that's the advantage of moving into this stuff and actually knowing what you're doing with object-oriented programming, because it might appear more than you think. So yeah, with that, that's kind of what the new diagram will look like. And again, we've had to do a lot of restructuring. This is kind of the end here. This is like the diagram that we had to make, or that I had to make. So this is what's going to have to happen in 2.1 to kind of like, we don't want to immediately switch over into this new system immediately, because then it's a lot of work up front. We kind of want to like work in stages. So at first we have the front end on top, and this is kind of like our whole database or whole backend that we have now. But now we have to talk to this API gateway and stuff, and other things like Cloudflare to get that working. But eventually, through version 3, we'll be able to get rid of all of that fluff, and then it'll be something that's super, super simple and coordinated across the world, and anyone can play it anytime. So these are kind of the key takeaways here in the last couple seconds. But yeah, I think you guys have classes to go to. If you'd like to play the game, it's the URL. But to end off, thank you guys so much for coming and listening to the talk.